Okay, pre-calc, here it is. This is the last section of new material of the year. So we've made it this far. We're going to talk about Pascal's triangle, section 10.5. Okay, so what we're going to do is we're going to use Pascal's triangle. We'll introduce what that is, and we'll show you how we write binomial expansions by using it. All right, so what is Pascal's triangle? So first thing to think about is our guy Pascal came up with this, discovered this, that a binomial, just kind of understand that a binomial is an algebraic expression involving the sum of two unlike terms. So for example, down here, like A plus B, okay? So we come up with an important series, since we're talking in chapter 10, series and sequences. An important series is generated by the expansion of a binomial raised to an integer power. So if we go ahead and keep raising it to a power, an integer. We can take a look at this generated by the expansion of a plus b to the n power for several non-negative integer values of n. So it's got to be positive. We can go 1, 2, 3, 4, 5. And as you can see, it kind of forms like and expands out and forms like a triangle. So that's why it kind of came up with Pascal's triangle. Okay, so let's take a look at some of the things here of this triangle, though, and we'll kind of point out these things from this triangle above. So each expansion has n plus 1 terms. So when you look at it, when we look at what we're doing here, when we go from the first expansion here, we have 1 term, right? So this has 1 term, the next one has 2 terms, this one has 3 terms, this one has 4, 5, 6, and so on. So it's always going to have an extra term in there, okay? The first term is a to the nth power, the last term is b to the nth power. So I just want to point that out as well, that when we do this one, we can see that the first term, let's just look at squared here. The first term is a squared, the last term is b squared, okay? So we kind of look at that. The next one, so we kind of looked at these two already. Here's this one. In successive terms, the powers of a decrease by 1, and the powers of b increase by 1. So the first term is going to go in descending order, while the second term is going to go in ascending order. So the first term, a, as you look in this, look at a plus b to the 4th. So your a variable, your a term goes 4, 3, 2, 1, 0. And your second term, your b, goes the opposite way. It goes 0, 1, 2, 3, 4. Okay? And the sum of the exponents of each term is equal to n. So again, if we take a look at that real quick here and say, let's look at the third one, the third power. Okay? Now let's actually look at the fifth one. It's easier to see. When I add up the exponents, 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3, 1 plus 4, 0 plus 5. So it kind of has that pattern to it, and it'll go on and so forth, and it'll always equal the 5 here, okay? And because they're going, the first term is going in descending order, 5, 4, 3, 2, 1, and the other term is going in ascending order, 0, 1, 2, 3, 4, 5, that's why we have that for us. Okay, so it kind of makes that pattern. And then finally, the coefficients here, the ones in red, they increase and then decrease in a symmetric pattern. Okay, so we just kind of take a look at these. You can see this is 1, it's the only term. This is also just going to be 1 and 1. So the outside of the triangle is always going to be 1, as you can see here. On each edge, the coefficient is going to be 1. But in the middle here, we end up adding and increasing and decreasing in a symmetric pattern. Okay, so when we think about that, we really need to get to like the third term here. When we look at this one, we go up and then we go back down. Okay, for the next term, we're going up, or we stay the same and then we go back down. All right, this one, we're from 1, we go up to 4, we go up to 6, then we go down to 4, and then down to 1. Okay. Same thing here. We increase to 5, increase to 10, stay the same at 10, decrease to 5, decrease to 1. So it'll always increase its way up to the middle and then decrease the way back down. Okay? And the last thing is about the coefficients is that we can find that. We'll kind of look at that in the next paragraph of stuff here. And we talk about Pascal's triangle. So this is a triangular array of numbers such that the first and last number in each row are 1. We kind of talked about that. And every other number is formed by adding the two numbers immediately above that number in the previous row. Okay? And n plus 1 row contains the coefficients of the terms of the expansion a plus b to the nth power for n, 0, 1, 2, so on, so forth. Okay? So for example, this part right here where it talks about each coefficient is 1, but every other number is formed by adding the two numbers immediately above that in the triangle in the previous row. Let's take a look up here. Okay? When we look at here, this 2 is formed from 1 plus 1. Okay? This 3 here is formed from 1 plus 2. Okay? This 4 here is added from 1 plus 3. This 6 comes from this 3 and this 3. This 4 comes from this 3 and this 1. So we're always adding it up. And that last one, again, the 1s are always on the outside. So this 5 comes from 1 plus 4. This 10 comes from 4 plus 6. This 10 comes from 6 plus 4. This 5 comes from 4 plus 1. And then 1 on the outside again. So hopefully you get the idea of the triangle and how we add them up to get your coefficients. Now, they may change when we have certain numbers and certain values in for A and B, and that's what we have to multiply by, but the same pattern is going to stay the same. And so we kind of get the idea here in the, with the rows, you can see how they add up. Like we just kind of talked about, this 6 is 1 plus 5, this 15 is 5 plus 10, this 20 is 10 plus 10, and so on and so forth to get those numbers, okay? So it keeps expanding as we get larger. All right, I left a little space there because I'm going to write there when we get to the examples. But here we go. How to expand a binomial by using Pascal's triangle. All right, so the first thing we're going to do is we're going to determine the number of terms by adding 1 to the exponent. Okay, so no matter what the exponent is given to you, we're going to add 1. That way we know how many terms we're going to have to write. Then we're going to write the series for the corresponding row by using the pattern of increasing and decreasing exponents, right? Remember, your first term, the exponents are going to go down. And your second term, the exponents are going to start at 0 and go up. And then we're going to omit the coefficients right away. We're not even going to use those right away. We can put in the coefficients later on. And then if necessary, we might have to extend Pascal's triangle to determine the coefficients of each term. If necessary, you can use this right here because this is going to give you that's always going to be the case for Pascal's triangle, unless we get above 6 or 7 rows or 8 rows. But you can always use this for those first 6, and it'll help you out. Okay, so we'll kind of refer to that triangle as we go along. And then simplify the exponential expressions. We're going to multiply to get, use powers, exponents, and then multiply by coefficients to simplify it. And then remember, if we have exponents of 0, that becomes 1. Exponents of 1 obviously become just the base number. Last thing, to expand a binomial difference, rewrite the expression as a binomial sum. So that's just the case if we have like a minus b squared, we're just going to rewrite it as a plus negative b squared. Okay, just rewrite it as a sum, and then we can do the same thing. All right, let's get to the practices. All right, so first thing to do, we looked at this one, we look at our notes, follow along, use Pascal's triangle to expand each binomial term. All right, so the first one here, we're going to look, we say it's got an exponent of 8, which means it's got 9 terms because it's 1 plus the exponent, okay? So we know a plus b, we're just dealing with a plus b here, so we can rewrite this out. So I know that the first term, if I look back at my triangle here, I'm going to go down here and just reference this just to help us out, because the next one, as we draw these in, if I drew them, would be so the next row, if I continued along here, would be we'd have a 1 over here. And then we'd have a 7, right? Because this 1 plus 6 would be 7. Then we'd have 21 because it's 6 plus 15, 35, 35 again, 21, 7, and 1. So you can see the pattern. And that is for that next row. We need to go one more row because we're going to the 8th power here. So if I went one more row, I'd go 1. 1 plus 7 is 8. 7 plus 21 is 28. Then I have 56 in here. 70 because 35 and 35. Then I'm going to kind of go decrease in the same pattern. 56, 28, and 8. And then 1 would be my last coefficient to the outside. Okay? So now that I know that is kind of what we're looking at, we can add those in. We can add those in later. All right? We can add those in later. Right now, I'm just focused on getting the ascending and descending exponents. So the first thing I'm going to do is I'm just going to say, all right, I know that my first term should be a to the 8th power. Okay? And then b is going to be to the 0 here, but I'm not even going to write that down, right? Because I know that's going to be 1. I may use it later on when I have other coefficients, but I'm just going to leave it like that right now. And then I'm going to just keep writing here A7, B1, right? I'm going to kind of write as with the coefficients, A6, B2 plus A5, B3. Because remember, all we're doing here is we're saying it goes, the A's go down, the B's go up. Try to grab this, move these over a little bit. Okay, good. And 2 more here. So it does take a little while, but that's okay. A1, B7, and then finally A to the 0, B to the 8th power, which I could just leave as B to the 8th. All right, now let's kind of put in those coefficients. So I'm just kind of using these when it's an A plus B. I'm just kind of using these as my coefficients, and I'm just going to write them in where they go. So this one here is a 1. It's going to stay the 1. I'm just going to stay A sub 8. I'm just going to use blue just to show that they're there, just so they show up a little better. The next one was an 8, right? The next one was a 28. The next one was a 56. Then we had 70. Then we had 56 here. And then we had 28. Back to 8. And then finally back to 1, which I don't even need. And I can probably get rid of that A sub 0 as well. And there you have it. That is our expansion when it's an A plus B. Okay? All right, but what if it's not A and B? What if it's actual values there? So let's look at the next one. Okay? So in this case here, let's first note that we've got 6 terms, right? Because it's going to be 5 plus 1. And really, this is going to be our A value, and this is going to be our B value. So now I can go ahead and I can use Pascal's triangle over here and say, since I'm going, it's going to be, basically I'm saying it's A plus B to the 6th power, right? Or sorry, to the 5th power. A plus B to the 5th power, but just 2x is my A, 3y is my B. So I'm going to use A plus B to the 5th power here, which is pretty much this one here. So I know that those are the coefficients I'm going to use. Or maybe I'm using, these ones here, right? So we'll use those later. We'll talk about them as we go, but let's just start by getting in the exponents. So the first one I know is going to be 2x to the 5th. And I'm going to use parentheses here. And I'm actually going to write the 3y in here now, 3y to the 0. Okay, then I'm going to do that again, but it's just going to be ascending. 2x to the fourth times 3y to the first. So the 3y is going up, the 2x is going down. Plus 2x to the third times 3y squared plus 2x to the squared times 3y to the first power. Oops, sorry, to the third power. And then 2x to the first power times 3y to the fourth power. And finally, the last one is going to be 2x to the 0 power times 3y to the fifth power. Okay, so the first term went 5, 4, 3, 2, 1. The second term went 0, 1, 2, 3, 4, 5. All right, now we've got to add those coefficients that we were just talking about in front. Okay, so to do that, again, that's where I referenced these two lines. 6-termer, 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. Okay, so I'm going to place this one in front. 1. This one's 5, 10, 10, 5, and 1. Now we've got to do some multiplying and simplify this thing with our exponents. Okay, so remember, we're kind of doing all of this together. So what we're doing here is we're saying 2 to the fifth. Remember, this is 2x to the fifth power. So it's 2 to the fifth, which is 32 times 1. And we know this is 1 also. So really, we're left with 32x to the fifth, right? Again, just looking in that, 2 to the fifth power is 32. X to the fifth power is x to the fifth. 1 and 3y to the 0 is 1. So let's continue now. And this one, you've got 16x to the fourth, but you're then multiplying it by 5, and you're also multiplying by 3y. So really, you're multiplying the coefficients of 16, 5, and 3. That's going to give you 240. X to the fourth. Notice that the exponents stay the same. So they're still in descending order for the x's, and the y's will be in ascending order. Okay, next for one, you've got 2 to the third power is 8 times 10 times 3 squared is 9. So it's really 8 times 10 times 9, which is 720. X to the third, y squared. So really, this is just about the coefficients. Your exponents are going to stay the same. Your variables stay the same. In this one, 2 squared is 4. 3 cubed is 27. So 4 times 27 times 10 gives us 1,080. X squared, y cubed. And then over here, 2 to the first power is 2. 3 to the fourth is 81. So 2 times 81 times 5 gives us 810. X, y to the fourth. And then finally, you've got this is 1, this is 1. And so it's just 3 to the fifth. 3y to the fifth power is 243, because 3 to the fifth power is 243. Y to the fifth power. And that is our expanded binomial using Pascal's triangle because of the series. All right, now, what if it's a difference? We talked about that. What if it's a difference? Well, this is going to be only 4 terms because it's 3 plus 1. If this is basically saying a minus b to the third power, or we want to rewrite it as a sum, so a plus negative b to the third power. So we're going to kind of use that triangle form, a plus b. So when we go back to Pascal, we're looking at this row right here. Okay, but we're just saying that our a value is 2x and our b value is negative 7. Okay, so we're really saying it's 2x plus a negative 7 as our terms to the third power. So let's write it. We know it's only going to be 4 terms. So the first one is going to be the first term, 2x cubed, because it's the first one we start with. And then we can put the second term times negative 7, which can put parentheses around here. To the 0 power. Okay. And I'm putting parentheses because I know I'm going to add those coefficients later on. Then I'm going to go with 2x squared because I'm just descending order here. Negative times negative 7 to the first power. Then it's going to be 2x to the first power times negative 7 squared. And then finally, our last term is going to be 2x to the 0 power times negative 7 cubed. All right. Now the coefficients, right? So I'm using this part of the triangle. So it's going to be 1, 3, 3, and 1. 1, 3, 3, and 1. So I go to write that down here. So 1, 3, 3, and 1. So I can multiply that by 1, by 3, by 3, and by 1. So now I'm simplifying with the exponents. I know this is 1. I know this is 1. So my first term is just going to be 2 to the third power, which is 8x cubed. Okay. My next term, 2 squared is 4. So it's going to be 4x squared times negative 7 times 3. So it's going to be, actually it's going to be a negative 84 x squared. And we don't even need the y to the first because it's just a number. And then over here, again, because negative 7 is just numbers, so it's always going to work out here. So 2 to the first power is 2. And then times 3. And then negative 7 squared is positive 49. So that's going to be 294x. Once again, you've got 2 times 49 times 3. And then over here, I know this is 1. I know this is 1. So really, I'm just looking at negative 7 to the third power, which is negative 343. So it's just a bunch of multiplication and using exponents once we get our coefficients in there. All right, last one. Again, so now this is going to have 5 terms because it's to the fourth power. Okay, so we're going to be kind of targeting this one here, a to the b to the fourth. So it'll be 1, 4, 6, 4, 1. Those will be the coefficients. I might write those down just to remember them. 1, 4, 6, 4, 1. So we think 1, 4, 6, 4, 1. Those will be the coefficients that we use. Okay. And again, I'm just going to be writing this as like 2x plus minus 3y to the fourth power. All right. So let's plug in our terms. I know it's got 5 terms. So I'm going to go ahead and say this is 2x to the fourth times negative 3y to the 0 power. Okay. And I'm going to do that again with just descending on 2x to the third, negative 3y to the first as they're going up in powers. The next one, 2x squared times negative 3y squared plus 2x. Going down one more, negative 3y cubed, and then there's one more here, which is 2x to the 0 and negative 3y to the fourth power. Again, you don't have to write to the 0 power because you know it's 1, but it just kind of helps me to put these all in so I know. Okay. All right, our coefficients, right? So 1 is going to go here, 4 is going to go here, 6 here, 4 here, and 1 over here. So now we can do the multiplication and finish this up. So again, this is 1 times 1, and so it's 2 to the fourth power, 16x to the fourth. Okay, this term, the next term over here, I've got 2 to the third power is 8. Okay, 8x cubed. I've got negative 3 to the first power is negative 3 times 4. Okay, so I multiply those. I've got 8 times 4 times negative 3, which gives me negative 96. Don't forget my exponents, x cubed y. The next one, 2 squared is 4. This is going to be 9. So 4 times 9 times 6 is 216. X squared, y squared. And now here I've got 2. This is going to be a negative 27. So 2 times negative 27 times 4 gives me negative 216. It'll be x to the first power, y to the third. And finally, this last one, I know this is 1. I know this is 1. And then I've got Negative 3 to the fourth power is 81, a positive 81. Be careful with those negatives there. Y to the fourth. And there you have that expanded. It was a difference. We made it a sum. And we just used Pascal's triangle to expand that binomial. All right, great job. Answer any questions, bring them. We'll try to help you out as we go.